The overall conviction among most specialists is that the hypothesis of how things came to be stays the fundamental explanation for the early seasons of the universe. This speculation joins the progress of stars, planets, etc., remembering life for those planets, including ourselves. Not navigating, it's a genuinely odd hypothesis named the Big Bang. It offers an edifying appraisal concerning what could have occurred at first. The universe was thick in a short space, more certifiable than a pinhead, with particles thick and stupefied. From this moment, a giant impact of matter and energy happened, known as the Big Bang. This event, happening billions of years ago, set up the spreading out of tremendous history. However, levels of progress in certifiable data have set off developing peculiarities with the suspicions of this hypothesis. When NASA launched the James Webb Space Telescope, the best and most advanced space science observatory ever, specialists speculated that its insights would confirm the hypothesis of the universe's beginnings. Unfortunately, following a year in space, the telescope surprised specialists with its capacity to dock so profoundly into the universe's past. The James Webb Telescope's stunning limits have uncovered multitudinous worlds going as far back to a time so old that it challenges how we might decipher the universe's beginnings. This discovery has lighted an unprecedented evaluation into what existed before the Big Bang. One fundamental moment in this mission occurred when cosmologist Rohan Naidu, working with data from the telescope, unexpectedly viewed a universe from just a short time after the Big Bang, making it the most far-off universe ever seen. NASA's discovery sent shockwaves through established specialists, highlighting the incredible limits of the James Webb Telescope. Its fundamental goal to change our perspective on the universe has just begun, promising to reveal surprising insights into the earliest times of the universe's existence. This period, barely dissected beforehand, holds the key to understanding the advancement of the main stars and worlds. The telescope's exposures have conflicted with beginning hypotheses, uncovering systems with credits outperforming past assumptions. This exceptional flood of early systems has touched off a tempest of logical inquiry, inciting specialists to oblige these disclosures with existing theories. As researchers grapple with these revelations, they face urgent inquiries concerning the very nature of the universe and the powers that molded its advancement. Past the James Webb Telescope's headways, which are reliable, it is found 1.5 million kilometers away from Earth, protected from normal obstruction and cooled to almost absolute zero by its tennis court-sized sunshield. The telescope incorporates a large portion mirror and amazingly delicate instruments intended to uncover subtleties of the early universe, previously secret. This period, known as the extraordinary first light, occurred around 200 or 300 million years after the Big Bang, marking the moment when the primary stars and galaxies began to form. The interaction by which this unfolded remains a subject of serious study, with speculations ranging from the effects of dark matter and dark energy to the interactions between star-forming gas and dust. The telescope's perspective on galaxies from the huge first light presents a strange opportunity for cosmologists to test how they may decipher these complicated parts. By examining these ancient galaxies, researchers can either affirm the legitimacy of their current models or uncover gaps in understanding that could lead to vital new discoveries. At first, the telescope was supposed to observe a couple of feeble and small galaxies in its pilot studies. However, reality has far surpassed these presumptions. The telescope's initial images of the distant universe revealed a flood of galaxies with ages, sizes, and brightness levels that tested all expectations. This staggering flood of early galaxies has set off a race among space specialists to establish new records for the earliest known cosmic systems, with new discoveries arising consistently, leaving traditional experts in awe. Following the James Webb Telescope's discoveries, subject matter experts and onlookers have raced to study the presence of these exceptionally advanced early galaxies. Some speculated that errors in the telescope's understanding of major observations could be responsible for these unanticipated discoveries. That said, the consensus remains that these revelations represent a shift in the way we could interpret the early universe and offer an exciting glimpse into the potential for enormous advancement. The new revelations from the James Webb Space Telescope have raised central questions about the nature of the universe and challenged the assumptions of standard cosmological models. While some researchers are investigating whether these observations can be reconciled with existing theories, others suggest that they might be the first signs that the universe is far more complex and confusing than previously envisioned. The real question at hand is our fundamental understanding of how the universe we know emerged from primordial chaos. The early revelations of the JWST could reshape our core ideas of cosmic history, uncovering insights not only on distant galaxies and ancient structures, but also on the very nature of our own Milky Way. As Mark McFadden, senior researcher for science and investigation at the European Space Organization, puts it, "You build these machines not to confirm theory but to break it. You truly have no idea how it will break." The beginnings of the JWST can be traced back to the Space Telescope Science Institute, STSCI, in 1985, even before the Hubble Space Telescope was launched. At the time, G. Weir, then head of STSCI, was tasked with envisioning what could come after Hubble, despite initial doubts. Weir and a little bunch started laying the preparation for what might ultimately turn into the James Webb Space Telescope. Not at all like Hubble, which fundamentally catches apparent light, the JWST was intended to see in the infrared range, permitting it to peer much further into the universe. This capacity is essential for examining far-off worlds whose light has been extended into the infrared because of the expansion of the universe, making them undetectable to telescopes like Hubble. With its monster cold star-like mirror, the JWST became the chief instrument for opening the mysteries of an estimable sunrise. The requirement for the JWST was featured in 1995 when the Hubble Deep Field Observation revealed endless universes in what was accepted to be a void patch of sky. This discovery represented the lavishness of the early universe and highlighted the need for a telescope capable of examining much further into infinite history. After 20 depleting years of development and an expense of around $1 billion, the JWST was at last launched on December 25, 2021. By July 2022, it was prepared to begin its most significant year of logical observations. Early undertakings, such as the Early Release Science Program and the General Observer Program, were explicitly intended to look for early worlds. While initial assumptions were unobtrusive, the outcomes far surpassed them. JWST observations have tested existing models of the early universe, uncovering universes that oppose conventional cosmological suppositions. These amazing revelations emphasize the significance of pushing the limits of scientific inquiry and highlight the remarkable capabilities of cutting-edge technologies like the James Webb Space Telescope. As scientists continue to investigate JWST data, they may uncover further insights that test and expand how we comprehend the universe. When the first data started coming in from the JWST, cosmologists anxiously anticipated the outcomes. Many had been planning their data analysis pipelines for this moment for a long time. Instead of following the traditional peer review process, which often requires months, scientists decided to share their discoveries on preprint servers like AR14, a platform for research papers that haven't yet been peer-reviewed. This approach allowed for a new form of peer review to take place through social media platforms like Twitter, where independent specialists could rapidly discuss findings. Rohan Nada described this process as science by press release, and the following storm of conversation was both exciting and overwhelming. However, there were concerns about the possible downsides of this quick spread of results. A JWST project researcher at STSCI warned that while the rapid sharing of results facilitates quick dissemination and discussion, there is also the risk of overwhelming the process. The general understanding among most scientists is that the theory of how things came to be remains the main explanation for the early stages of the universe. This theory includes the evolution of stars, planets, and life on those planets, including ourselves. Despite its great name, the Big Bang provides a broad explanation for what could have occurred at the universe's beginnings. The universe was densely packed into a space smaller than a pinhead, filled with densely packed particles. From this moment, a massive explosion of matter and energy occurred, known as the Big Bang. This event, happening billions of years ago, set the stage for the unfolding of cosmic history. However, changes in scientific data have led to growing irregularities with the assumptions underlying this theory. When NASA launched the James Webb Space Telescope, the largest and most advanced space science observatory ever built, scientists speculated that its observations would support the theory of the universe's beginnings. Sadly, After only 1 year in space, the telescope astonished researchers with its ability to peer deeply into the universe's past. The James Webb Space Telescope's exceptional capabilities have revealed galaxies dating back to such ancient times that they challenge our understanding of the universe's origins. This discovery has ignited intense examination concerning what existed before the Big Bang. These revelations have sparked rigorous investigation into what may have existed prior to the Big Bang. While the findings from the James Webb Space Telescope continue to challenge our understanding, they are opening new avenues for exploration and discovery. Many scientists now believe that the answers to some of the universe's most significant questions might lie in these early observations, and that our current models may need to be revised or entirely reconsidered. The existence of these distant, ancient galaxies suggests that the universe might have evolved in ways that were previously unimaginable. It also raises fundamental questions about the very nature of time, space, and cosmic development. The implications of these discoveries extend far beyond the field of cosmology. They have the potential to reshape our understanding of physics, the laws governing the universe, and even the origins of life itself. As the James Webb Space Telescope continues to gather data, its revelations could offer significant insights into the earliest moments of the universe, the formation of the first galaxies, and the very processes that led to the rise of stars and other cosmic structures. These discoveries could ultimately help answer long-standing questions about the beginnings of the universe and the forces that shaped its development, providing a more complete and accurate picture of our astronomical history. In the years to come, scientists will continue to study the data returned by the JWST, refining their models of the early universe and testing new theories about the primordial forces and particles that shaped the cosmos. As the telescope reveals more about the universe's past, we will come to learn more about the present and future of our universe. The James Webb Space Telescope has already proven to be a landmark instrument, and its discoveries will likely continue to surprise and inspire the scientific community well into the indefinite future.